So let's start by looking at an overview of the actual software itself. So the Carlson BlastOps software. So it allows you to bring in Quarryman or drone point cloud data. So you can bring in this data into the software. You can then bring in drill hole data, QC checks with your bore track. So you can assess the borehole deviation and calculate your burden charts. You can create blast pattern layouts. You can work with your burden measurements for hole loading. You can then load the holes and quality check the timing and the initiation. So all of this happens within the software itself using the different modules within the BlastOps software. I guess that diving down a little more deeper into it, you kind of have these 4 pillars. And Gordon today is really going to touch on the first one in this first session that we're running today, and that's the cloud and mesh editing. So Gordon's going to run through how to bring in the Quarryman and drone point cloud data, how to combine scan sets, how to edit it, and then from there create your surface, which then becomes your base or your surface that you're using for all of the other future tools and workflow processes that you might want to use. Some of those things could be your pattern layout and analysis, your drill hole loading, initiation, creating your contour lines for the timing. And then with all of this, you have this ability to extract the data. You can send your hole locations out to GPS or to drills. You can send your burden measurements and hole loading information to the blasters. And you can push information via Carlson command to smart equipment. So you have this back and forth communication between the office and the field. So that kind of wraps up the overview of the software and what we're hoping to cover today. And I'm gonna pass this off to Gordon, and Gordon is gonna run through a couple data sets with you to kind of show you how you would get started with the software and run through some of the basic tools in terms of the point cloud manipulation and surface generation. So hang on one second while I pass the microphone over to Gordon.
Thanks, Gavin. As Gavin mentioned, today we'll be going over the importation of drone or Quarryman data into our BlastOps software, which is comprised of 2 components. We have our Cloud Commander as well as our Blast Commander. So because we're dealing strictly with the point clouds today, we'll be mainly staying into Cloud Commander. So opening this up, we'll be able to either open a project or create a new project. So I'm just going to call this webinar and create it. So here is our main interface for Cloud Commander. The very first thing that we'll do is going into our project settings, go into our units. We'll make sure we're in the correct unit system before importing any data. Just quickly going through the rest of this dialog, we're able to enter any company information, bring in a company logo or watermark in order to attach it to the reports. We're able to import or input stuff about the project, the operator. And here we also have the ability to sign into Carlson command. So that is our machine control modules in order to push the drilling information to the equipment in the field and receive that back as well. The very last one is scenes. We could change it between perspective and orthographic, change our controls between default and Mac, and change our background color. As we can see, mine is black here behind the window. So going back into this main screen, we have tabs along the top, kind of explaining or going through the different steps before bringing this into Blast Commander. And then below that, we have subcategories to use in each of these tabs. So in our project tab, we could change our project. And this is where a lot of our importation will be. Our load point file is typically for our drone data sets, or really any kind of data set. we could bring in LAZs, LASs, text files, or XYZs. And if you do use the Carlson photo capture software, the export from that will easily be brought into here. So just quickly, opening up an LAS file here, you can see how well that imports in. We're able to move it around, look at it, and there's not all that much to be done with the drone point clouds. There might have been some equipment in the field that we might have to take out. That's not the case in this. Maybe what we'll do instead, we'll just delete that out, and let's bring in a different data set where we might have some more cleaning to do. So here we can see we have our driller up on the top along with a pickup. And we also have some noise down here below. And so in order to clean those up, we have under our editing tab, a very simplistic remove or keep filter. We have the options of a polygon selection or a box selection, and then the ability to undo that last selection or clearing them all. And then we also have a selection behavior. So by default, it's left on outside. So if we go with our polygon tool and we click the vertices around a number of points here, those points will disappear. Now we could also switch those to inside so that it just focuses on that. Or especially if we're filtering just specific points right now, we can leave it on highlight in order to see what we are removing. Now, the one thing to note is that we can't switch between keeping points and deleting points. So if we've decided to delete these points, we can't then go in with another polygon selection, select an area, and then say that one I want outside. So the selection behavior goes to all of our polygon and box selection tools, previous and future. So that's something, sorry, to keep in mind when you're cleaning up your point clouds. Now that being said, we could remove that last one, or we could clear them all. Now, I've really focused just on the polygon selection tool. It's a very flexible, easy to use. We could choose up to maybe 1, 2, 3, 4, 5, 6, 7 vertices before it does. I guess timeout's not the right word, but maxes out and finishes it for us. And so there we're not clicking and dragging. We're just clicking the vertices, and then it'll stitch or enclose the vertices we've selected together. But let's look at the box selection tool. So the box selection tool, you'll notice, comes in, and this will be either bigger or smaller depending how zoomed in we are. And right now it just has a very distinct outline to it. By clicking the tool again, we're able to bring up the editing features with it. So the circles on the extents of the box are in regards to its its extents or its perimeter. So maybe we'll raise that top one out. We could also translate it. So using the middle axis here, we could either translate it up on our Z, X, Y, and then actually the quarter circles here act as a rotation. So we could rotate the box just around the Z axis, or we could rotate it along any of the axes that you could see. And then once we're happy with that, we could just simply left click the box again in order to bring out that outline so it's not so distracting. And then we could continue on to something else. Now, the other thing we also have is the inside all. So maybe I'll drag this out. Actually, yeah, I'll drag this out just momentarily. And what I'll do is I'll actually create another box here, just to show you that one specific feature. So here, maybe we have just the 2 cars that we're interested in as opposed to the 3. And if we go inside all, maybe we should select inside as our behavior, we would see that rather than inside both of the boxes, it's in both of the boxes that we're looking at. And then if we're looking the opposite way, then outside. So that is your editing features right there in a nutshell. Next, before we go into Blast Commander, is our surfacing tab. So this uses Poisson's algorithm in order to create our mesh surface. Typically, our defaults here, Poisson detail of 8 and our Poisson trim of 7 gives us enough information to create a mesh. I would leave these as a default before creating the mesh, and then what we could do is manipulate the values afterwards. We also have this smoothing algorithm that gets rid of any kind of isolated points. So maybe some dust particles, anything like that. There's not a lot in this particular data set that we would need to filter out, but I typically just turn these on anyways before creating the surface. So here, our last button in our surfacing tab is our surface from viewpoint. So what's important is that we're able to see our face profile and as well as our top and bottom benches from a good vantage point, typically from the front, like I have it here, or even from the inside out looking, we're able to create a good surface. And so we would just click surface from viewpoint and allow that to compile the surface for us. And we can see we have our surface here. And what I'm going to do is I'm actually just going to turn off this point cloud just to show you the mesh on its own. And what we'll do, just to show you what these two features do. So our trim allows us to I guess gape across any missing areas of data. So on this one, we didn't really have any. The previous one I did, you might have noticed that there was some missing data in the face. So by lowering this, we're able to expand our triangles. And so as I lower this even further, you'll notice that this will continue to expand out. And so same goes vice versa. So if we don't want it to jump across certain points, we could reduce that down. And you can see the higher we go, we might not even stitch across a lot of the points. So as I mentioned, 7 is a good default there. More for the Quarryman points, you might have to lower that depending on the density of points you have in your scan. And we'll come across that in a bit. Poisson detail is essentially just the sheer amount of points we're going to be using to create this mesh. So the higher it is, the smaller the triangles, the more, the bigger the file. So our PLY, if we go into our objects and we go into our drone data mesh here, we can save it as a PLY or a TIN. And so the higher the detail, the bigger that file would be. Now, while the trim does change the surface as we go, the detail does not. So if we were to change that detail, we would have to recreate our surface just by simply clicking surface from viewpoint in order to redefine our mesh. Now, coming back to bringing back our point cloud, the last thing we might want to do before bringing this into Blast Commander is actually just inserting some colors. So maybe we've just collected this with a UAV. We didn't have someone with a rover pole to pick up any drilled holes. Maybe we already have the drilled holes. Rather than picking up the hole locations with our quarryman or our GPS, we'd be able to see potentially some holes drilled along the top here, just based off of our imaging. And we could actually go in and insert some colors, and maybe the holes would be next to it. Again, back on that other data set, it was actually a little easier. But here I'm just going to create some holes that if we turn it off, we won't see them from the top, but we will see them from the bottom. And so those will be imported along with our mesh into our Blast Commander so that we could attach our bore track data to it, or use those rough locations as our design locations for our pattern layout. However they want to be used. And so that is it for our drone process here in Cloud Commander. What I'm going to do is just delete these out just quickly, and then we'll look at our Quarryman data. So the first Quarryman file I'm actually going to do is a local grid file. And what I mean by that is that we don't have a geo-reference position to any of our Quarryman stations. So that in this, it's very important that we, if we're doing multiple stations with our Quarryman, that we have some reference back to our previous Quarryman station in order to stitch the two data sets together. In this case, the file I'm about to show you, traverse was done around a stockpile, so we have four stations set up, each with a backside and foresight to another station. So in this case, we're only going to create one location or station for our very first Quarryman station, and we're just going to label this Station 1, or our Quarryman Station 1 at 100, 100, 100. And so we're just going to activate this so that we can see it pop up here in the viewer. And we're going to go next. So under our data import is where we bring in the Quarryman FSC file. Here we could change the units that the Quarryman was using in the field. And here we could choose what template we have. Right now we have the default template, but if we switch to my own template here, just a left click would allow this to appear, and then left click to apply would show it's highlighted. Now we have a recommended loading template for our files that you can see in the window in front of you, namely between, well, 0 and 0 is our reference direction. Again, more for our local grids. 1 to 49 are our observation stations, so whether this is for our resection or GPS backsite points or Quarryman stations, this is what will be included in here. Now we could have some shots of the floor as well as a line to represent our toe and crest, which you'll notice the feature type over here to the right. So we have our target, scan, line, and collar, and then different colors if we choose to change those. So yeah, toe and crest for our line. Our hole colors will be anything in the 60s using our collar feature type. And then mostly our scans 80 to 100 that I've put as white just because of the black background. And this will give you your scan feature type. So what that does is when we do import our FSC file, is allocate these codes automatically. So by bringing in or choosing our FSC, it allocates all the different codes automatically. So here under Station 1, we could see our foresight and backsite to Stations 2 and 4, as well as our toe, and then the scan from that location. And that breaks it down by each station. And actually going into number 1, we could see that our backsite here to number 4, we had 4 readings. Whether or not we want to use all 4 of these or average them out can be our choice. We could actually go out and delete these if we wanted to. Maybe I'll focus on the one in the middle, so I'll just use the very first one, and we'll save that. And so yeah, we could see the amount of readings taken here, and we could open these up and take a look at these this raw data and delete what we don't want, or we could continue on. So by going to next comes to our alignment. So because we have our 4 stations, we need to align this data. So GP, we already have a ground control point, GCP 1 found that we entered ourselves as 100, 100, 100. And then from here, we also shot in station 2. So in the background, the software will be calculating the position of station 2. And then from that, station 3, from that, station 4, and so on and so forth. So really, all we really need to do here is enter initial direction for our very first station. So we could just say known direction at startup and say it was either north, east, south, or west if we wanted to. The other option is because in this specific case, our shot to station 4 was actually what we turned our Quarryman on, we could say that our shot to station 4 was our initial direction of north. And then we don't need to indicate anything else here because again, for station 2, 3, and 4, we have a front sight, we have a back sight, so everything will be positioned relative to this first station. So we could just carry out our ServNet alignment here. And we'll see a grid plot on the right showing the different locations. And we do pass it through a statistical validation, but because we're doing in a local grid, there's nothing to really validate. So we'll see that when we actually look at the scene in our next window. So here's where we'd actually create the scene with our Quarryman data. And once it's been rendered, we could view the scene here. So we could see the 4 different stations we were set up on, how they tie into each other, and then the stockpile that's in the middle. And just to give you a better idea of what data comes from what Quarryman, we could actually go into our settings here and go into point cloud settings. This could also be brought up just by the blue arrow on the left-hand side. And we could change our point sizing, we could change the shape of our points. But what I'm really doing here is I'm just gonna change the color. Maybe we'll do one red and another one we'll leave as yellow, and then maybe the third one we will color blue, just to give you an idea of what data came from each of the Quarryman setups. And really from here, we would just go to our editing, maybe rather than take out all the points on the outside, and I just want to focus on the stockpile, I would use my box selection tool to finesse that. And maybe I'll go highlight at first, which with all the different colors is a little interesting, but we'll continue on here. And then we'll switch to inside. Surfacing, maybe we won't have our detail all the way up at 14, we'll leave it at 8, and we'll look from again, inside out to create our mesh or surface. So here, the trim's way too high. We could just see that it has that one little gray spot here. So what we'll do is that we'll lower this down. And I'll turn off the point clouds just so we can see that compile as we reduce that. And so maybe because we're looking to calculate the volume of the stockpile in Blast Commander, we'd want that top to be enclosed as well. So we'll just lower that just a little bit more till we get that. From there, We go to FSC Wizard. Our next step is editing and surfacing, which I just did in the main window. So our last step here would be exporting the mesh and the line work to Blast Commander to then do our volumes. So that's a local grid. The one last example that I want to touch on is actually using a GPS. And actually, we haven't talked a lot about measuring yet, so I'll touch base on that during this last data set. The last one I'm going to do is very similar to a, I should have done that before. It always self-renders after the fact. Okay. You know what? I'm just going to start fresh. Sure. Maybe we'll get rid of that. That control point. So here, I'm actually going to switch my units to Imperial. We're not going to be dealing with weights and power densities, but that's just habit. So FSC Wizard here, rather than just creating a point, we'd be importing a file. Now, this is typically from our GPS, or so we would have maybe if I was going to the right location, we could see we have a caller CSV as well as a control point CSV. So by loading that, we just have our code or station ID followed by our X, Y, Z, and then an optional active column, which just represents a true or false. It doesn't necessarily have to be in this data. We're always able to switch it around if the X and Y are reversed. And we could also change the delimiter. So for those that use a different delimiter, we'd be able to change that to accommodate that, and then also skip any lines that might have headers or information that we don't want. So by importing it with the active column true, these would all just be checked off. Otherwise, we'd have to manually do that. So keep that in mind. And so next, very similarly, we're actually in Imperial Quarryman scan units this time, but still using the same template. We're able to bring in that FSC file. So here we just have our station 1 and 2, and because we're using a GPS reference, we just have a known position for our quarryman and then a known backsite. So we only have our one backsite here, as opposed to when we would use a resection and known points around a quarry, serving those in where we'd need 3 or more shots in order to determine the position of the quarryman. So very simple setup here, just a backsite and a scan. So if we go next, because we have our positioning, because we have our direction, because we physically shot that backsite in, we don't have to do anything on the screen. We could just carry out that ServNet alignment. Click next, and the scene will self-render. Just, I guess, one thing to note is that if we go to view scene, something doesn't look correct, we go back to the FSC wizard. If we go change our alignment or our coding in here, when we do get back to our render point cloud, we'd have to re-render the scene ourselves, as opposed to having it done for us. So viewing the scene, we could always see that it looks correct. We could see if we drop down our scene explorer here, we could see how one was at the top of the bench, the other one was just the front of the bench. And we're very happy with it. So last time I went through the editing and surfacing tab normally. If we go next, we would click edit point cloud to bring us to the editing tab. Otherwise, if we were to click make surface, it would bring us to the surface tab. Now, I did promise to go over the measurements tab. Nothing very complex in here. Just a number of different measurements that we can take on a point cloud. So we can measure the angle between 3 known points. We could just get a position for a point. We could get that distance between 2 points. Same for the height, so vertical height as opposed to a sloped height, as well as an area, which maybe I should have zoomed in on that more. The area does come up in the middle. But yeah, very self-explanatory measurement tools in the software here. But in this case, maybe, again, rather than deleting what's inside, we would go just choose our box selection. And here's where highlight would come in, so that maybe we don't want those points on the front of our face. So we'd reduce those out. And once we're happy with our selection, turn it to inside, surfacing. And then again, we don't have a lot of data on the top bench here. So if we were looking to design, which in this case we weren't, there was a lot of drilling happening at the time, which is why we have a number of bumps on the top surface there, all the different mounds from all the different holes being drilled. But lower that trim again if we wanted to get a little bit more of that top surface. And you can see that eventually, without any data, it does start to curl up there. So always be aware of that. And same goes for the bottom. Ideally, it'd be good to have some of the floor in front of the face, so that the face doesn't extend down past where it's supposed to. But again, from there, we'll go next and then export this to Blast Commander. From there, we do our burden measurements by bringing in our bore track, designing our blast pattern, using our surface, and then later on, as Gavin mentioned, doing our drill hole loading, as well as our timing and initiation. But that is essentially a run through of Cloud Commander and the import of point cloud data into Carlson BlastOps.